When you gaze at the moon, hanging like a silver coin in the inky sky, do you ever pause to consider the immense timescale involved and wonder about the true beginning of the Earth beneath your feet? The very ground we stand on has a story to tell, a history etched in fire and time. Our planet was not always the serene blue marble we know today. It was once a seething ocean of molten rock, a world born in fire, not tranquility, a crucible of unimaginable heat and relentless volcanic activity. To truly understand ourselves, our origins, we must embark on a journey back 4.6 billion years, a staggering expanse of time, to a time when Earth was a newborn, a raw, untamed sphere screaming into the silent void of space. Forget the familiar image of blue oceans and green continents. Instead, picture a sphere of liquid fire, a molten ball of rock and metal, suspended in the absolute darkness of space, radiating intense heat and light. This primordial epoch is known as the Hadean Eon, Earth's infancy, a crucible of unimaginable chaos and intense heat, a period unlike anything we can readily comprehend. Relentless bombardment by asteroids and meteorites coupled with unimaginable surface temperatures defined this violent and formative era. There was no solid ground to be found, only a thick toxic atmosphere and vaporized rocks swirling in the extreme heat. This isn't a scene from science fiction, it's the established consensus of modern geology and astronomy, pieced together from countless observations and experiments. To truly appreciate the calm and beauty of today's Earth, we must confront and understand our world's incredibly violent and chaotic birth. The iron that flows within your blood, carrying life-giving oxygen, the calcium that forms the very structure of your bones, they all in some way passed through this ancient planetary fire, forged in the heart of a molten world. So let's embark together on a journey of discovery, guided by the light of science and driven by curiosity, to witness firsthand the incredible birth of our world, the planet we call home. We'll explore how cosmic chaos, the seemingly random collisions and forces of the early solar system, ultimately gave rise to order and stability, and how, in the grand scheme of the universe, Earth's story is inextricably linked to our own story as human beings. Our journey back to the very beginning of our planet is, in a profound sense, a journey home, a quest to understand where we truly come from. The story of our solar system, and indeed our own planet, is one that stretches back billions of years. It's a tale of cosmic dust, gravitational forces, and unimaginable heat. Our solar system began as a vast, spinning cloud of gas and dust, a swirling vortex of elements and potential. This cloud, immense beyond comprehension, held the seeds of everything that would eventually come to be. This nebula was the remnant of a star that had lived its life and met a spectacular end, a dying star collapsing in on itself before exploding in a supernova. Gravity, the architect of the cosmos, began to exert its influence. It pulled this cloud together, slowly but surely, spinning it faster and faster as it contracted. The pressure and temperature at the center became immense until finally, nuclear fusion ignited. A new star, our sun, was born, blazing into existence at the heart of this swirling cloud. But the sun's birth was not the end of the story. The leftover material, the gas and dust that hadn't been incorporated into the star, flattened into a disk, a vast plain of swirling particles. This protoplanetary disk became a cosmic construction zone, a place where the building blocks of planets would begin to assemble. Tiny grains of dust, microscopic particles floating in the void, began to collide and stick together, drawn together by electrostatic forces. These clumps grew larger, becoming pebbles, then rocks, then boulders, slowly accumulating mass as they swept through the disk. This chaotic process, driven by gravity and collisions, is called accretion. It was a messy, violent, but ultimately creative process. This was a demolition derby on a solar system scale. A cosmic game of bumper cars with planet-sized consequences. Planetesimals, the building blocks of planets, smashed together at tremendous speeds, their surfaces scarred and cratered by countless impacts. Sometimes these collisions were destructive, shattering the planetesimals into fragments. Other times, they were constructive, merging the bodies together into something larger. And so, Earth was born from this relentless ballet of collisions, a slow and violent accumulation of cosmic debris. Each impact added mass to the growing planet, increasing its gravitational pull and drawing in even more material. Each collision also unleashed tremendous heat, generated by the kinetic energy of the impactors being converted into thermal energy. Billions of impacts rained down upon the young Earth, a constant bombardment that shaped its surface and interior. The cumulative effect of all this heat melted the young Earth into a global ocean of magma, a sea of molten rock that covered the entire planet. As Earth grew larger, its gravity became stronger, further intensifying the heat-trapping process. Gravity trapped this heat, preventing it from radiating away into space and keeping the planet in a molten state. But there was another, equally important heat source contributing to Earth's fiery state: radioactivity, the decay of unstable elements within the Earth's interior. Unstable isotopes like aluminum-26 and uranium-235 decayed over time, releasing energy in the form of heat. This radioactive decay released even more heat into the Earth's interior, supplementing the heat from impacts and gravitational compression. This radioactive furnace deep within the Earth played a crucial role in shaping the planet's early evolution. Together, these heat sources ensured Earth remained a glowing, molten sphere for millions upon millions of years, a crucible forging the planet we know today. Our world's fiery birth was a period of intense heat, constant bombardment, and dramatic change. It was forged in the chaos of the cosmic forge, a testament to the power and violence of the early solar system. The stage was set, the players were in place, for the next act in Earth's dramatic story. A cataclysmic event, a cosmic collision of unimaginable scale, that would forever alter the course of Earth's history and pave the way for the world we inhabit today. In the chaotic ballet of the early solar system, as planets were still coalescing from dust and gas, Earth was not alone. It shared its orbital space with a Mars-sized protoplanet, a celestial body scientists have poetically named Theia. This smaller world was on a collision course with destiny and with our own planet. Their paths, once separate, converged in a cataclysmic collision, a cosmic event of unimaginable scale. This impact was the most significant event to shape our planet after Earth's initial formation, a pivotal moment in its early history. Theia, a cosmic wanderer, slammed into the young, still molten Earth with tremendous force. The collision released an almost unfathomable amount of energy, a surge that rippled through the nascent solar system. The force of the impact was so great that both bodies were not merely dented but shattered into countless fragments. In the aftermath, a vast plume of vaporized rock and molten material was blasted far out into space, a fiery spray of planetary debris. This ejected debris, a swirling cloud of superheated matter, gradually coalesced, forming a ring of fire around the wounded Earth. The ring was a spectacle of incandescent material, glowing intensely with residual heat from the colossal impact. Over time, the relentless pull of gravity began to work its magic, drawing the molten fragments inexorably together. And so within a relatively short span of thousands of years, a new celestial body began to emerge from the chaos. This marked the tumultuous birth of our moon, a cosmic phoenix rising from the ashes of planetary collision. It is a sibling, forever bound to Earth, quite literally torn from Earth's own primordial flesh in this violent encounter. This dramatic sequence of events is best explained by the giant impact hypothesis, the leading scientific theory that elucidates why the moon is surprisingly large relative to Earth, and why its composition is so remarkably similar to Earth's mantle. Furthermore, the giant impact hypothesis elegantly accounts for Earth's unusual axial tilt and its relatively rapid spin. Every time we gaze up at the moon in the night sky, we are witnessing a constant reminder of our planet's incredibly violent past. The moon is more than just a distant satellite, it is our cosmic sibling, forever intertwined with our own destiny. It is a testament to the raw power of the early solar system, born from the same cataclysmic fire that shaped our own world. The seemingly quiet and serene moon that hangs above us is in reality a relic, bearing the scars of unimaginable violence etched across its ancient surface. Our world and its lunar satellite are inextricably linked, forever bound together by the echoes of this ancient, colossal impact, a defining moment in the history of our planet and its celestial companion. After the moon-forming impact, Earth was a world of chaos, a global ocean of magma. Imagine a sea of liquid rock glowing orange-white with temperatures of thousands of degrees. The sky was a dense shroud of vaporized stone, raining molten rock back into the churning lava below. Asteroids and comets still bombarded the surface, sending up splashes of magma. Beneath, immense convection currents stirred the molten planet, remaking its face in hours. Occasionally, minerals with high melting points crystallized, forming fleeting crusts, dark rafts on the lava sea. but these fragile crusts were quickly destroyed by impacts or remelted by convection. No land, no water, no life, only fire and constant change. The dream of a solid Earth was still distant. This was a world in perpetual turmoil, forging the foundation for what would come next. The first hints of stability were still millions of years away. Deep within the molten Earth a transformation began, planetary differentiation. The heaviest elements, mainly iron and nickel, sank toward the center, forming a dense, superheated core. This iron catastrophe released even more heat, keeping Earth molten longer. Lighter silicate minerals floated upward, creating the mantle and eventually the crust. Think of it as a cosmic salad dressing separating into layers. This separation established Earth's internal structure: core, mantle, and crust. The iron core would one day generate a magnetic field, vital for life. The lighter materials formed the foundation for continents and oceans. Out of chaos, order emerged, a planet with layers, ready for the next chapter. The stage was set for geology, plate tectonics, and the possibility of life. The elegant structure of Earth was born from molten disorder. Earth's first atmosphere was nothing like today's blue sky. Outgassing from the molten planet released a toxic mixed carbon dioxide, nitrogen, and immense amounts of steam. The pressure was crushing, the greenhouse effect extreme. Surface temperatures soared above boiling. The sky was a murky orange, storms raged, and it rained molten rock. No oxygen, no life. Just a primordial soup of potential. Yet this atmosphere held the seeds of the future: nitrogen, carbon, and water. As the planet cooled, these ingredients would shape a more hospitable world. The toxic shroud was the first step toward the air we breathe today. How do we know what Earth was like billions of years ago? Geologists are detectives reading clues in ancient minerals and meteorites. Tiny crystals called zircons found in Australia are over 4.4 billion years old. Their chemistry suggests liquid water existed surprisingly early. Meteorites, unchanged for billions of years, reveal the raw materials that built our planet. They confirm Earth's elemental recipe and help us model its formation. In labs, scientists recreate early Earth's conditions, squeezing and heating minerals to extreme levels. These experiments show how elements separated into core and mantle. By piecing together zircons, meteorites, and lab results, we reconstruct Earth's fiery birth. The story is written in stone, space, and science. Our understanding grows with every new clue. The sinking of iron created more than Earth's structure. It forged a magnetic field essential for life. The liquid outer core churns, generating electrical currents and a powerful magnetic field, the geodynamo. This field extends into space, forming the magnetosphere, our shield against the sun's deadly solar wind. Without it, Earth's atmosphere would be stripped away, as happened to Mars. The magnetic field protects our air, water, and the possibility of life. It was established early thanks to Earth's molten beginnings. The same heat that formed the core still drives the geodynamo today. Our planet's magnetic heart is a silent guardian, born from ancient fire. It created a stable cradle for life to begin. Our fiery origin gave us a life-saving shield. Early Earth was chaos and fire, yet every violent step was necessary for life. Cosmic collisions built our planet and delivered life's raw materials. The molten world allowed iron to sink, forming the core and our magnetic shield. Outgassing created the first atmosphere and delivered water for oceans. Today's volcanoes are echoes of that hot past still shaping our world. The heat from radioactive decay drives plate tectonics and mountain building. The iron in our blood, the carbon in our DNA, the water in our bodies, all forged in Earth's ancient fire. We are stardust processed through a planetary crucible. Our connection to this violent world is unbreakable. Next time you stand on solid ground or drink water, remember the journey those atoms took. From a dying star through a magma ocean to you, Earth's story shows how chaos can give rise to order, stability, and life. From a sphere of fire a cradle was born, and we are its children. Imagine standing on the surface, if you could even survive, of a newborn Earth, a planet still in its infancy. The ground isn't solid rock, it's unstable, shifting. It's a glowing sea of molten lava, stretching as far as the eye can see. The air? Not air at all. Not in any breathable sense, but thick, scalding steam, a constant reminder of the planet's fiery core. 4.5 billion years ago, a time almost beyond comprehension, Earth was wrapped in a suffocating veil of vapor, a dense shroud obscuring the surface. No oceans to reflect the light, no continents to break the monotony, no life, not yet, just a furious, superheated fog, swirling and churning with unimaginable energy. The heat radiates from below, an intense, palpable force, and presses down from above, a crushing weight of atmospheric pressure. The sky is a ceiling of roiling gray and brown clouds, a canvas of perpetual storm, pierced only by flashes of lightning, brief, violent illuminations in the gloom. The only light comes from the lava's orange glow, a flickering, unreliable source, and those brilliant, terrifying storms, crackling with raw power. The sound is a constant roar, a symphony of destruction and creation, hissing steam, rumbling rock and volcanic explosions, a never-ending chorus. No peace, only violent motion, a planet constantly reshaping itself, magma bubbling up, a fiery display of the Earth's inner turmoil, crust forming and vanishing, a fleeting illusion of stability. This was a world in chaos, a crucible where the elements battled for dominance, creation and destruction in every moment, a dance of cosmic proportions. Earth was building its atmosphere from the inside out, a slow and arduous process. The very violence that made the surface uninhabitable, the relentless volcanic activity, was delivering the key for the future. Water, the lifeblood of the planet to come. Locked in steam, a hidden potential, water waited for its moment to transform the planet, to sculpt its landscapes and nurture life. Understanding this primordial greenhouse world, this seemingly hostile environment, is about tracing the steps that turned a ball of hot rock into a living world, a testament to resilience and adaptation. The veil of vapor was a critical stage in Earth's history, a necessary prelude to the world we know. It's a far cry from the blue marble we know today, a serene oasis in the vastness of space. This is the story of how our home in the cosmos began, a journey from fire to life, and how, from fire and steam, the raw ingredients of a planet, a world for life, was forged against all odds. What is the source of all this steam billowing into the atmosphere? What primordial process could possibly generate such a spectacle? The answer lies deep within the heart of the planet, in the fiery crucible of Earth's interior. Early Earth was a churning, incandescent ball of molten rock, a seething cauldron of unimaginable heat and energy. This molten sphere was constantly releasing gas through volcanic outgassing, a planetary belch of epic proportions. Volcanoes acted as the planet's release valves, venting gases trapped inside the Earth's mantle for eons, spewing out a cocktail of chemical compounds that would eventually coalesce to form our atmosphere and oceans, the very cradle of life. And what was the most abundant gas in this primordial exhalation? Water vapor, H2O, the life-giving molecule, but in those early days far too hot to exist as liquid water. Superheated steam blasted skyward with tremendous force, ultimately trapped by Earth's relentless gravitational pull. Layer upon layer of this vapor accumulated year after year, millennium after millennium, steam accumulated for millions upon millions of years, creating a dense, opaque atmosphere. This relentless volcanic activity, this constant outgassing, built our planet's first atmosphere, a process that was both destructive in its immediate impact and profoundly creative in its long-term consequences. Alongside the dominant water vapor, volcanoes also release significant quantities of carbon dioxide, nitrogen, methane, ammonia, and a variety of noxious sulfur compounds. The result, a thick toxic chemical soup, a far cry from the air we breathe today, utterly alien to life as we currently understand it. The gases came out from the Earth's interior, but they didn't go back in. Earth was actively shaping and defining its own environment, one volcanic eruption at a time. Without this crucial period of outgassing, Earth might have ended up as just another dry, barren, and airless rock in the vast expanse of space. Instead, this volcanic exhalation provided the essential raw materials, the very building blocks, for the formation of our atmosphere and the eventual creation of our oceans. This primordial veil of vapor was the direct and unavoidable result of this intense period of planetary venting. It was a crucial and transformative phase, Earth letting off steam, quite literally, fundamentally setting the stage for everything that was to come, for the evolution of life itself. The planet's breath, in its infancy, was both a curse of toxicity and a promise of future habitability, and this great volcanic exhalation would irrevocably change the world forever, shaping the destiny of our planet. Life on early Earth's surface? Impossible. The ground was a vast, roiling magma ocean, no continents, no mountains, just molten rock. Occasionally a thin crust formed, but it was quickly swallowed by the fiery sea. Above, a permanent shroud of dense, swirling cloud steam, carbon dioxide, Sulfur blocked all sunlight. The only illumination lava's glow and constant lightning. Heat came from within, not the sun, as radioactive decay and collisions kept the surface molten. The thick atmosphere acted like a pressure cooker, trapping heat and creating an extreme greenhouse effect. Surface temperatures soared, keeping water as vapor. The boundary between ground and sky was chaos, hot gases rising, turbulent winds whipping across fire, no gentle breezes, only scalding storms. This was Earth at its most primordial, a world of fire and steam. The planet was forging its identity in the crucible of the early solar system, and the stage was set for transformation. Early Earth's atmosphere wasn't just hot, it was crushingly heavy. Atmospheric pressure may have been over 200 times today's, with an entire ocean's worth of water suspended as steam. This immense weight kept water as gas, raising its boiling point to several hundred degrees. Even as the surface cooled, water couldn't condense. The pressure cooker effect locked the planet in a steamy state for millions of years. High pressure shaped geology, pressing down on magma and making crust formation difficult. Any new crust was stressed from below and above. The planet was squeezed from the outside in. This high-pressure era was a barrier to oceans forming. Only when the planet cooled and pressure eased could water finally condense. The end of this era would be one of Earth's most dramatic shifts. The veil of vapor's atmosphere was a reactive chemical kitchen. Volcanoes spewed water vapor, carbon dioxide, nitrogen, methane, and ammonia, ingredients for life. Lightning strikes, far more frequent than today, energized the sky, breaking and reforming molecules. This reducing atmosphere was perfect for building complex organic molecules, amino acids, nucleotides, the building blocks of life. The surface and sky exchanged chemicals, creating a feedback loop. The chemistry of the sky shaped the crust, and the crust shaped the sky. In this high-energy, high-pressure environment, the pathways for life's chemistry were forged. Life couldn't survive on the surface yet, but the atmosphere was busy creating organic ingredients. When the rains finally came, these molecules would be delivered to the forming oceans. The veil of vapor was a chemical incubator, preparing Earth for life's next chapter. How do we know what Earth was like over 4 billion years ago? The answer: zircon crystals, tiny, durable time capsules formed in cooling magma. Some zircons found in Australia are over 4.4 billion years old. By analyzing their oxygen isotopes, scientists can tell if they formed in the presence of liquid water. Remarkably, these ancient zircons suggest liquid water existed much earlier than once thought, perhaps in cooler, localized pools. Isotopic signatures in ancient rocks reveal clues about the earliest atmosphere and its volcanic origins. It's planetary forensics piecing together a crime scene billions of years old. The Hadean Eon was dynamic and varied, not just a uniform steam world. Zircon crystals are our direct witnesses, silent messengers from a world on the cusp of forming its first oceans. They tell the story of a planet beginning to cool, ready for transformation. The veil of vapor couldn't last forever. As Earth cooled, volcanism waned, and the atmosphere stopped being replenished with steam. Eventually, the temperature dropped enough for water vapor to condense. At first, rain evaporated before reaching the ground, a phantom rain. But cooling continued, and finally, the first drops splashed onto volcanic rock. This was no gentle shower, but a deluge, thousands, even millions of years of rain. The entire water content of the atmosphere poured down, carving channels and pooling in basins. The sound was a planet-wide roar as water met hot rock, creating clouds of steam. With every drop, the atmosphere thinned, pressure eased, and the sky began to clear. For the first time in eons, sunlight broke through. The Great Deluge delivered the oceans and unveiled the planet. The era of the veil of vapor ended. The era of blue sky and sunlit sea began. Earth was transformed, ready for the next chapter. The world was finally open to life. The veil of vapor's story is deeply connected to life's origins. That steam-filled atmosphere, rich in methane and ammonia, was perfect for forming complex organic molecules. The Miller-Urey experiment showed amino acids could form in such conditions. Early Earth was a planet-sized chemical factory, churning out life's raw materials. When the rains came, they washed these molecules into the new oceans, creating a nutrient-rich soup. The veil of vapor was a preparatory phase, creating oceans and delivering the ingredients for life. This blueprint guides our search for life on other worlds. A young rocky planet with a thick, steamy atmosphere might be on the path to habitability. The journey to a living world is long and complex with distinct stages. By studying our own past, we sharpen our search for life across the cosmos. The clearing sky, a breathtaking transformation unfolding before our very eyes, marked the end of one of Earth's most dramatic chapters, a pivotal moment in its long and storied history. It signified a shift, a departure from the old, and an embrace of the new. The transformation from a steam-shrouded world, a planet cloaked in a thick, impenetrable fog, to one with blue skies, a vibrant, life-giving atmosphere was the greatest climate shift in history. And oceans was the greatest climate shift in history. The birth of our oceans, vast and teeming with potential, forever altered the course of our planet. The sun became the main source of light, bathing the earth in its radiant energy. The moon began to shape tides, orchestrating the rhythmic dance of the oceans. The water in our oceans, the lifeblood of our planet, the rain, even our breath, all trace back to that ancient volcanic steam, the primordial soup from which our world emerged. That water has cycled through Earth for over 4 billion years, an endless journey of evaporation, condensation, and precipitation. Our atmosphere today is a descendant of that first chaotic steam-filled sky, a testament to the Earth's enduring power of transformation. Greenhouse gases once kept Earth molten, a fiery, uninhabitable landscape. Now they keep it comfortable, a delicate balance, a precarious equilibrium that sustains life as we know it. The veil of vapor shows how a planet's atmosphere shapes its destiny, dictating its climate, its potential for life, and its place in the cosmos. The sky above is not just empty space, but a dynamic part of our world, a constantly evolving system that influences everything from the weather to our very existence. From a wall of steam to a window on the cosmos, Earth's journey is one of resilience and change, a story written in water and vapor etched across the face of time. The sky we see today is a gift from our planet's steamy, tumultuous past, a reminder of the incredible forces that have shaped our world. Imagine Earth, not as the vibrant blue marble we know today, but as a hellish, molten sphere, a crucible of fire and fury. Picture a world unrecognizable, a landscape forged in the heart of a star. There was no blue sky, no gentle breeze, just a churning ocean of magma stretching as far as the eye could not see. A sea of liquid rock, constantly roiling and spitting, a testament to the immense energy within. Above this fiery sea, a suffocating, toxic atmosphere choked the planet. A dense cloud of noxious gases, a barrier to any form of life as we understand it. From the cosmos, asteroids and comets relentlessly bombarded the surface, a cosmic hailstorm of destruction. Each impact a cataclysm, reshaping the landscape in fiery explosions. These celestial impacts were not just destructive, they were also adding heat and chaos to an already volatile world. The energy released further fueled the planet's internal fires. Water, the lifeblood of our planet today, existed only as vapor, trapped in a dense, steamy haze. It was locked away, unable to condense and form the oceans that would one day teem with life. The atmospheric pressure was crushing, a weight that would instantly obliterate any unprotected object. The air was thick with carbon dioxide and nitrogen, a poisonous cocktail. High above, the young sun, still in its infancy, cast a dim red twilight through the haze. Its light struggled to penetrate the thick atmosphere, painting the landscape in shades of crimson and shadow. Days lasted only hours, a fleeting glimpse of light amidst the darkness, fueling violent storms that raged across the planet. These were not ordinary storms, they were planetary-scale events. These storms whipped the toxic gases into a frenzy, creating swirling vortexes of destruction that tore across the molten landscape. A truly hostile environment. Deep beneath the chaos, heavy elements like iron and nickel, drawn by gravity's relentless pull, sank to form the core of the planet. This was the beginning of Earth's magnetic field, a shield that would one day protect life. Closer to the surface, lighter minerals began to cool and solidify, forming the planet's first fragile crust. This was not the stable ground we know today, but a thin, easily broken shell. These early crusts were constantly shattered and recycled by constant volcanic upheaval. Immense eruptions ripped through the surface, spewing lava and ash into the atmosphere. Yet with each passing moment, heat escaped into space, radiating outwards into the cold void. This slow but steady process was the key to Earth's eventual transformation. This gradual loss of energy was inching Earth closer to a cooler future, a future where liquid water could exist and life could begin to take hold. a future far removed from this fiery past. The stage was set, the players were in place, and the conditions were slowly changing. The planet was poised for a transformation that would change everything, forever altering its destiny. The greatest storm in history, a cataclysmic event that would reshape the planet, was about to begin. An event that would pave the way for the world we know today. As Earth's surface gradually cooled over eons, a pivotal moment approached. The molten rock, once a sea of fire, began its slow transformation. The thick, dense atmosphere, heavy with water vapor, was finally reaching a point where condensation could occur. The temperature was dropping, allowing the invisible vapor to coalesce. The first raindrops to fall were not the gentle, life-giving drops we know today. Instead, they were scalding, searing droplets, born from a superheated sky. Each drop, upon striking the still scorching rock surface, would hiss violently, instantly vaporizing back into steam, a fleeting dance of water and fire. The ground fought back against the rain, but the relentless cooling continued, a slow but inexorable shift in the planet's climate. The surface temperature edged lower, degree by agonizing degree. And soon, the atmosphere, saturated and heavy, was ready to unleash a deluge unlike anything the young planet had ever experienced. The sky was pregnant with rain, a storm of unimaginable scale brewing. Clouds thickened into monstrous formations, swirling masses of dark gray and black, blotting out the faint light from the distant sun. The world beneath was plunged into an eerie twilight, shrouded in a stormy gray veil, a premonition of the cataclysm to come. The landscape held its breath. The atmosphere, now completely saturated with water vapor, could hold no more. It was a pressure cooker ready to explode. It reached a critical breaking point, a threshold beyond which there was no return. The forces of nature were about to be unleashed. And then it began. Rain began to fall everywhere simultaneously across the entire globe. This was not a mere drizzle, not a gentle shower to nourish the land. It was a heavy, torrential downpour, a planet-wide torrent of biblical proportions. The heavens had opened. Each drop, a tiny messenger from the sky, carried away a minuscule amount of heat from the surface. This constant barrage accelerated the cooling of the rocky crust, solidifying the ground beneath the relentless rain. The more it rained, the more intense the downpour became, a self-perpetuating cycle of atmospheric fury. The more water vapor condensed into rain, the more clouds formed, creating an even greater capacity for precipitation. It was a powerful feedback loop, a runaway weather system that would reshape the planet's destiny. The sky was not just weeping with gentle tears, it was unleashing a torrent, preparing to flood the world in a cataclysmic event. This was no ordinary storm, no fleeting squall. It was a fundamental transformation, a geological event billions of years in the making, a turning point in Earth's long and turbulent history. The planet braced itself for a downpour of unimaginable intensity and duration, a downpour that would scour the surface, wash away the old, and prepare the way for the new. The immutable laws of physics had meticulously set the stage for this grand spectacle. And now, the rain, in its relentless and transformative power, would change the face of Earth forever, carving new landscapes and shaping the continents to come. The greatest flood in the planet's history, a deluge that would echo through the ages, was about to begin its relentless reign. The rain began and it didn't stop for millions of years. Imagine a world shrouded in darkness, battered by a relentless, deafening downpour. The rain was acidic, falling through a sky thick with volcanic gases eating away at the newborn crust. Every drop dissolved minerals, carving and reshaping the surface. The atmosphere held several times the water of today's oceans, all of it had to fall. The storm was a planetary-scale event, washing and scouring and cooling the Earth. As rain fell and evaporated, it vented heat into space, taming the planet's fiery past. The endless deluge-filled basins eroded rock and set the stage for the next chapter. The great downpour was not just weather, it was planetary engineering. When the rain finally slowed, Earth was forever changed. The fever had broken, the world was ready for something new. The relentless rain, a constant companion to the young Earth, didn't just pool on the scorched surface. It wasn't content to simply gather in puddles. It moved, driven by gravity's unyielding pull. It began its long journey back to the lowest points on the planet. This water, in its persistent flow, began carving the first rivers and canyons into the raw volcanic rock. It was a slow, grinding process, but the sheer volume of water and the immense timescale made it an unstoppable force. Water, as it flowed, dissolved minerals from the rocks it touched, enriching itself with the planet's very essence, making the rivers salty and giving them a unique chemical signature. The rivers, now laden with dissolved minerals and sediment eroded from the highlands, began carrying this precious cargo to low-lying basins, shaping the landscape as they went. These flows were savage, untamed, and powerful. They were a force of nature unleashed upon a world still in its infancy. The water, with its abrasive power, was cutting deep into the crust, relentlessly grinding away at the volcanic rock. This process of erosion and deposition was gradually shaping the planet's first drainage patterns, a network of waterways that would define the continents for eons to come. The rain, in its ceaseless cycle, redistributed the very substance of the crust, moving mountains of rock and sediment from one place to another. This constant movement and erosion were fundamentally transforming the landscape, slowly but surely sculpting the features we would recognize as continents. As the rain continued to fall, water gathered in vast impact basins, the scars of ancient asteroid strikes, and in areas where the crust was sagging under its own weight. These depressions gradually filled, forming lakes of all sizes, from small ponds to vast inland seas. These lakes eventually merged and expanded, creating shallow seas that stretched across the landscape. And finally, after countless millennia, these seas coalesced to form the first true oceans, vast bodies of water that would cover much of the planet's surface. Imagine a world of stark contrasts: black rock, the product of volcanic fire, and a gray sky, perpetually overcast with volcanic ash and steam. Now, picture the first glint of water, reflecting the faint sunlight, filling ancient chasms and craters, a sign of the life-giving force that was transforming the planet. These primordial oceans were far from the clear blue waters we know today. They were hot, heated by the Earth's internal fires. They were also acidic, due to the abundance of volcanic gases dissolved in the water. And they were murky, filled with dissolved minerals and suspended particles, obscuring the depths below. These oceans were a far cry from today's blue seas, a testament to the dramatic changes Earth has undergone over billions of years. Yet within these turbulent waters, in this chemical soup, something extraordinary was about to happen. Within these churning depths, the next stage of Earth's evolution was brewing, a stage that would forever alter the course of the planet's history. The planet now had a solid crust, a foundation upon which life could eventually build. It also possessed a thinner atmosphere, still rich in volcanic gases but slowly evolving towards a more stable composition. And most importantly, it had vast bodies of liquid water, a solvent that would facilitate the complex chemical reactions necessary for life to emerge. Earth had become a chemical laboratory on a planetary scale, a giant crucible where the ingredients for life were being mixed and heated. The stage was set, the players were in place, and the conditions were ripe for the most incredible experiment of all, the emergence of life. Life's ingredients, the fundamental building blocks of all living things, were ready to mix, to combine, and to spark the beginning of a new era on Earth. With oceans formed, Earth became a giant test tube for life. The early seas were a chemical broth, rich with minerals and gases from the crust and atmosphere. Energy from the sun, volcanoes and lightning powered reactions among simple molecules. Amino acids and nucleotides, the building blocks of life, began to form. Some scientists point to sunlit pools, others to deep-sea vents as the birthplace of life's chemistry. In either case, liquid water was essential. Over millions of years, some molecules began to self-replicate, perhaps forming the first primitive cells. The great downpour didn't just fill the oceans, it created the arena for life to begin. The great downpour broke Earth's greenhouse fever, thinning the atmosphere and cooling the crust. Acidic rain pulled carbon dioxide from the air, locking it in rocks through the carbonate-silicate cycle. This buried greenhouse gases, stabilizing the climate and allowing liquid water to persist. With a thinner atmosphere and oceans to absorb heat, temperature swings mellowed. Life could finally gain a foothold in this stable environment. The rain also launched a new water cycle: evaporation, clouds, rain, and renewal. This cycle became the engine of Earth's climate, driving weather and delivering fresh water. The violent birth of the water cycle gave way to the balanced system we depend on today. The great downpour was the planet's thermostat, setting the stage for life. Earth was now ready for its next chapter. The legacy of the great downpour is everywhere. Every rainfall is an echo of that ancient planet-shaping storm. The water in your glass once fell as scalding rain on a newborn world. Sedimentary rocks, river valleys, and the saltiness of our oceans all trace back to that first deluge. Even life itself is a living memory of those primordial seas. Our bodies are filled with salty water, a reminder of our oceanic origins. The rain connects us to the deep past, to the forces that shaped our world. Every storm is a link to the story of Earth's transformation. The ancient rain still shapes our lives today. Rain is life. It irrigates crops, fills rivers, and sustains forests. Without it, civilization would collapse. With it, the planet thrives. But rain is more than utility. It's a symbol of renewal and power. For millennia, we've looked to the sky for rain's blessing or mercy. The great downpour was both destructive and creative, dissolving rock to make life possible. This paradox is at the heart of nature. Creation and destruction intertwined. A single drop of rain holds the memory of its cosmic journey and the story of life's emergence. When rain touches your skin, you connect with the ancient forces that shaped our world. It's a reminder of our origins and our dependence on this beautiful, violent cycle. We are children of the storm, living on a planet where the sky once wept life into being. Our search for life in the cosmos is a search for worlds that had their own great downpour. We look for planets in the Goldilocks zone where liquid water and rain can exist. Earth's story shows how rare and fragile this process is. Venus became a furnace, Mars, a frozen desert, both missing the balance that made Earth habitable. The great downpour was a contingent miracle, a result of perfect conditions. It reminds us that a planet is a process, not just a place. The rain bridged the gap between a molten rock and a living world. As we alter our own climate, we're tampering with the system the ancient rain set in motion. The story of the first storm is both a lesson and a warning. The fate of tomorrow's rain is in our hand. Picture Earth over 4 billion years ago. Imagine a world utterly unlike the one we know today. Not a blue marble, but a seething inferno, a landscape forged in fire. The planet was a molten sphere, a glowing orb of liquid rock, its surface a churning ocean of magma, a sea of fire stretching as far as the eye could, well, if there were eyes to see it. Beneath a sky thick with toxic gases, a swirling orange-tinged atmosphere choked with volcanic fumes. No continents, no oceans, no familiar landmarks. Just relentless volcanic activity and cosmic bombardment, a constant barrage from space. Asteroids and comets slammed into the surface with unimaginable force, each impact reshaping the landscape, vaporizing rock in colossal explosions, and keeping the planet in a perpetual state of chaos, a world in constant flux and destruction. The atmosphere was a suffocating mix of carbon dioxide, a blanket of greenhouse gases, nitrogen and water vapor, creating a dense and oppressive environment, trapping heat in a runaway greenhouse effect, making the surface temperatures soar to unimaginable heights. Volcanoes split the thin crust, tearing open the planet's surface, spewing lava and gas into the already overburdened atmosphere, shaping a world in constant upheaval, a landscape sculpted by fire and fury. The air reeked of sulfur and burning rock, a pungent and acrid smell that permeated everything. The sky glowed with fire and falling debris, a constant reminder of the planet's violent beginnings. Yet even in this hellish landscape, this seemingly uninhabitable environment, the seeds of transformation were sown, the first whispers of a different future. Despite the heat, the intense radiation, and the constant bombardment, Earth's gravity held onto a thick atmosphere, a crucial shield against the harshness of space, including water vapor from deep within the planet, released from the Earth's mantle. This steam, released by volcanic outgassing, a constant process of planetary respiration, would become the most crucial ingredient in Earth's story, the key to unlocking a world of life. The chaos of this era was not just destruction, it was a necessary prelude. It was the beginning of something new, a foundation being laid for a future we can scarcely imagine. The relentless heat, volcanic eruptions and cosmic impacts, a seemingly destructive combination, were forging the conditions for change, slowly but surely shaping the planet's destiny. In this crucible, this fiery furnace of creation, the stage was set for Earth's next dramatic act, a shift from chaos to something more ordered. The planet was being prepared, through fire and fury, for a radical transformation, for the arrival of water, the lifeblood of our planet. The transformation from inferno to oasis was about to begin, a journey from a world of fire to a world of water. As the cosmic bombardment began to subside, the relentless barrage of asteroids and space debris gradually eased. The early Earth, once a chaotic and fiery realm, started its long journey toward stability. Earth began to cool, slowly radiating its immense heat into the vast expanse of space. This cooling process was essential, a necessary step in the planet's evolution. The molten surface, a sea of incandescent rock, gradually solidified, forming a thin, brittle crust, a fragile layer upon which the future of the planet would rest. This marked the birth of Earth's first skin, a protective barrier against the harshness of space. It was a pivotal moment in the planet's history. This crust, however, was far from stable. It was unstable, fractured, a mosaic of tectonic plates constantly shifting and grinding against each other. The Earth's internal heat relentlessly reshaped it, driven by the immense energy trapped below. Volcanic activity was rampant, a constant reminder of the molten core beneath. Jagged peaks sculpted by volcanic eruptions and tectonic forces and deep depressions carved by impacts and erosion marked the landscape, creating a dramatic and unforgiving terrain. These geological processes sculpted the planet's first basins, natural containers formed by the Earth's tumultuous youth. These basins, carved by volcanic flows, rivers of molten rock that reshaped the surface, and asteroid impacts, violent collisions that left lasting scars on the planet's face, became natural reservoirs, depressions in the landscape capable of holding vast quantities of liquid. Without them, water, when it eventually arrived, would have simply evaporated under the intense heat, unable to collect or persist. The basins were the empty cradles of future oceans, patiently awaiting the life-giving substance that would transform them. They were waiting for the rain, the long-awaited precipitation that would fill these empty spaces and begin a new chapter in Earth's story. Standing on this early Earth, you'd see vast empty expanses of shattered rock, a testament to the planet's violent past. Steam would be hissing from fissures, escaping from the Earth's still hot interior, and the ground would still be warm beneath your feet, a constant reminder of the molten core below. The silence was broken only by the groan of cooling crust, the sound of the Earth slowly solidifying and settling, and distant volcanic rumbles, the echoes of ongoing eruptions shaping the landscape from afar. These features were the architecture of our world, the foundation upon which all future life would be built. It was a landscape sculpted by fire and time, a testament to the immense power of geological forces. The formation of basins was a critical step toward habitability, a crucial prerequisite for the emergence of life. They set the stage for the next chapter, a chapter of transformation and renewal. The arrival of water, the lifeblood of our planet, was imminent. Earth's surface was ready. Now it needed to be filled, transformed from a barren wasteland into a vibrant, life-sustaining world. The planet was poised for a transformation that would change everything, ushering in an era of oceans, continents, and ultimately life itself. Where did Earth's water come from? The answer, both from within and from space. Volcanic eruptions released vast amounts of water vapor, venting it into the sky. Meanwhile, comets, icy remnants from the solar system's formation, bombarded Earth, delivering more water. For millions of years the surface was too hot for liquid water. Any that arrived instantly vaporized. The atmosphere became a dense, steamy blanket, saturated with water vapor. As Earth cooled, the temperature finally dropped below the boiling point of water. At last the vapor could condense. The sky, long shrouded in haze, was ready to break. What followed was a rainstorm of unimaginable scale, a deluge lasting thousands, even millions of years. Torrents of hot, acidic rain poured down, beginning the planet's first true water cycle. The greatest storm in Earth's history was underway. The basins waited, ready to receive the first drops. The era of water was about to begin. As the crust cooled, the sky unleashed a relentless, planet-wide downpour. Acidic rain, formed as water vapor mixed with carbon dioxide, carved channels into the barren rock. The rain dissolved minerals, transforming the landscape through chemical weathering. Water rushed into the deepest basins, at first forming hot, ephemeral pools. Much of it boiled away, but the deluge continued. Over time, the rate of accumulation outpaced evaporation. Pools became persistent, growing into vast, steaming lakes. The soundscape shifted from crackling rock to the roar of falling water. These were the ancestors of our oceans, murky, hot, and reactive. Water had finally found a home, setting the stage for the next transformation. The planet's surface was forever changed. The first rains did more than fill basins, they transformed the planet's chemistry. Acidic water broke down pristine igneous rocks, leaching minerals into the pools. Sodium, chloride, and other ions accumulated, making the water salty, a process that continues today. Hydrothermal vents on the basin floors pumped even more minerals into the mix. The result, a dynamic mineral-rich solution, warm and anoxic, under a red-orange sky. This strange brew was the perfect medium for complex chemistry. The early oceans were a bubbling cauldron of potential. The ingredients for life were coming together. As the relentless deluge persisted day after day, year after year, the landscape underwent a profound transformation. The constant rain carved pathways through the rock, creating intricate networks of channels, and as the Earth's crust gradually cooled, the intense volcanic activity that once dominated the planet began to subside, allowing the surface to stabilize. Basins, natural depressions in the rocky terrain, began to hold water year-round, no longer evaporating under the intense heat. These were the first signs of permanent bodies of water. Temporary pools, once fleeting mirages in a harsh landscape, slowly but surely became permanent proto-seas, expanding and deepening over vast stretches of time. This newfound stability allowed minerals, leached from the surrounding rocks, to accumulate in these waters, creating a rich chemical broth. This process made the water increasingly saltier and, crucially, more chemically stable, providing a more consistent environment for complex reactions to occur. The first seas provided a persistent environment, a stable foundation upon which the building blocks of life could begin to assemble. It was in these ancient waters that complex molecules could form, interact, and evolve, shielded from the harsh conditions on the surface. Evidence of these ancient waters, these primordial seas, is etched into the very fabric of our planet. It is found in the microscopic zircon crystals, some over 4.4 billion years old, tiny time capsules that hold secrets of the early Earth. These crystals bear the unmistakable signature of water, showing they formed in the presence of liquid water, a testament to its early abundance. These proto-seas were murky, likely greenish due to dissolved minerals, and warm, heated by the Earth's internal activity. An environment alien to us, yet absolutely crucial for what came next in the unfolding story of life on Earth. Without a protective ozone layer in the early atmosphere, incredibly harsh UV radiation from the sun relentlessly bombarded the surface of the planet, posing a significant challenge to any emerging life. Consequently, the deeper waters offered a vital shield, providing protection for the delicate and vulnerable chemistry that was just beginning to take hold. These stable, mineral-rich seas, sheltered from the worst of the sun's radiation, became Earth's first great laboratories, cradles of innovation, where the fundamental processes of life could experiment and evolve. The transition from small, isolated puddles to vast, interconnected seas was a pivotal turning point in Earth's history. The planet was no longer a world defined by fleeting, ephemeral puddles, constantly evaporating and reforming, but one characterized by enduring oceans, vast reservoirs of potential teeming with chemical possibilities. The essential conditions for the emergence of life were rapidly falling into place, creating a world ripe with opportunity. The story of water, from a scarce resource to an abundant presence, was now inextricably linked to the story of possibility, the potential for life itself. Earth's transformation was accelerating, moving ever closer to the dawn of life. Earth's surface was restless, shaped by shifting tectonic plates. As basins filled, geological activity merged them into larger bodies of water. Barriers eroded, lakes combined, and proto-seas became grander. Eventually these merged into a single planet-spanning ocean. This global ocean stabilized the climate, moderating temperature swings and supporting a robust water cycle. The planet transitioned from chaos to a regulated water world. Small volcanic islands dotted the vast sea, the first continents. Earth became a true blue planet, its surface dominated by water. The journey from hot puddles to a world-girdling ocean was complete. This ancient sea would define Earth's destiny. The stage was set for the next great experiment, life. The ocean was now the planet's most powerful force. The transformation was profound and irreversible. The stable oceans became Earth's greatest laboratory. They provided water, energy, and chemical building blocks, the essentials for life. Sunlight, lightning, and hydrothermal vents fueled complex reactions. The oceans were a soup of minerals and elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Here, simple molecules could combine into amino acids and nucleotides, the building blocks of life. Over millions of years, these molecules linked together, forming polymers capable of storing information and replicating. The deep ocean, especially around vents, offered protection and stability. The birth of the oceans was the birth of possibility, the origin of life itself. Earth's first oceans are the foundation of everything we know. They regulate climate, sustain life, and connect us to the planet's fiery origins. The water cycle that began with the first deluge still shapes our world. Ancient banded iron formations record the moment life began to change the oceans and atmosphere. Every glass of water is a link to this deep past. Molecules that have cycled through volcanoes, comets, and ancient seas. We are made of ancient stardust and primordial rain. The oceans are the cradle of life, the engine of our climate, and a direct link to Earth's birth. The story of water is the story of Earth, from molten chaos to a living world. We are the children of that ancient water, living proof of a cosmic inheritance. It all began with a single drop of rain,